folks, it's Mrs. Culver here. I promised you that we were going to do a little something about how action-reaction pairs and unbalanced forces work together. So here we are. That's our topic for today. I'd like you to recall Father Kevin's sermon on Friday. He talked about the cracked pot. The man who carried the water every day in the two pots over his shoulder. Okay? And one of the pots was cracked. So the pot that was cracked kept dripping water from it. So this is actually a perfect story to think about when we're thinking about action-reaction pairs and balanced and unbalanced forces. So here we go. Let's assume our man has just filled up both of the pots and he's put exactly the same amount of water in each pot, and each pot is hanging exactly the same distance from his center, from like the center of his chest. Okay, it's hanging out exactly the same distance from his center on a pole. Let's look at the action-reaction pairs that involve the pole hanging on the man's shoulders, resting on the man's shoulders. So this is how this works. That's a much better way to do this, isn't it? Okay. So we have the pole resting on the man's shoulders. All right. And there is an action-reaction pair of the pole pushing down on the man's shoulder and the shoulder pushing back up on the pole. And we have that on both sides here. Okay? Action-reaction pairs. Pole to shoulder, shoulder to pole. Pole to shoulder, shoulder to pole. And those forces, we know from Newton's third law, those action-reaction pairs, the force exerted by the pole on the shoulder is exactly equal to the force exerted by the shoulder back on the pole, pushing back on the pole. And as long as we have the same amount of water in each jug, the force pushing down on each side, on each shoulder, on the man's right shoulder and on the man's left shoulder, is the same. Right? This is equal to this, right? Because what we're talking about is the weight, the force with which half of the pole and the water pushes down on this side of the man's shoulder, the man's right shoulder. That force is exactly the same. It's the weight of the pole, of half of the pole and the pot with the water in it. Same thing over here on the other side. And so as long as we have the same amount of water in each pot, we have the same amount of force pushing down on each side of the man's shoulders. So those are balanced forces. Now we remember, of course, that one of the pots was a cracked pot. So as the man walked down the path, the cracked pot would leak water, right? And as it leaked water, that meant that there was less and less water in this pot, which now meant that there was less weight with this whole system here. There was less weight pressing down on the man's shoulder. So now this little force arrow becomes shorter. It's still, as it becomes shorter, the reaction force is the same as the action force. So the reaction force arrow becomes shorter. So now we have same force pushing down on the shoulder as the shoulder is pushing up with on the pole. Same force of the pole pushing down on this shoulder as is the force of this shoulder pushing up on the pole. But this force, these forces are smaller in magnitude than these forces because there's less weight on this side. And so what's going to happen? Well, of course, this pole is now going to tilt and fall, come down, unless the man uses his arm to exert a counter force, an amount of force necessary to equalize things again. And of course, if he does that, he'll put force on the pole with his arm, and of course the pole will put a force of the same size. Push that back up on his arm, right? Those will be two new action-reaction forces. And if the man puts just the right amount of force to rebalance our pots, then shouldn't it be true that the size of this force should equal the sum of this force and this force? Because if these are balanced, this force has to equal this force. And that would also mean that this force will equal the sum of, this reaction force will equal the sum of these two reaction forces over here. So there you go. That's action and reaction and balanced forces all in one go. Have a good evening.